Okay, so we have one more substitution problem here. We're going to take a look at a word problem. And remember, I know word problems can be a little daunting sometimes, but they actually give us context to the numbers. Instead of just giving you an equation that doesn't really have any meaning behind the numbers, the word problem just lets you know what do these numbers actually mean? How do we connect them to the equation? So we're still going to look at solving them in the form y equals mx plus b, which based on that title, I know they're going to give me the slope, they're going to give me the change, and they're going to give me the y-intercept, which is my starting point. And I know I did a whole lot of words kind of association with this in the first semester, where y-intercept is our starting point always, always, always. What did I start with? And the change is going to be change per something. In this case, it looks like we're driving, so it's going to be change per mile. Okay, so let's go ahead and read this. So Eric will rent a car for the weekend. He can choose one of two plans. The first plan has an initial fee of $44 and costs an additional 13 cents per mile driven. The second plan has an initial fee of $49 and costs the additional 11 cents per mile. So in this case, we come across this all the time as we get older and we become adults, is there's two options and we have to decide which option is the better one. And in this case, it's going to depend on how much he drives. Okay, so they're asking us to answer two questions here. For what amount of driving do the two plans cost the same? So they want us to figure out when are they equal to each other, and what is the cost when the two plans cost the same. So once we have the cost, once we know how many miles we drive to have the same cost for either plan, doesn't matter which one we choose, then they want us to find out, what is that actual cost. So for this one, I'm just kind of visualizing, here's Mr. Eric and here's the car to rent, right? We can hopefully picture that even if we've never rented a car before. And what do we know about plan one? Well, I know it costs $44 and 13 cents per mile. They told me that up here. I'm just rewriting it so that I can kind of think about that. So what is the starting point? Well, no matter what, he's going to have to pay that initial fee of $44, right? That's his starting point. So that's his y-intercept, which remember in the equation, that's our b. That's the number that's being added or subtracted. And what is the change per mile? Well, that's 13 cents, right? They told us that is 13 cents per mile. That's our slope. That's our change. Okay. So we will use, we're going to do this one first. I skipped right down here. We have a second equation, don't we? We have plan two. So what do we know about plan two? Well, we know it costs $49.11 per mile. Again, they told us that right up here in the equation. We're just rewriting it to kind of process the information. So our starting point on this one is that initial fee of $49. So this is going to be the y-intercept for the second equation. And what is the change per mile? Well, that was 11 cents per mile. So this one costs a little bit less at the beginning, but more per mile. This one costs a little more at the beginning, but less per mile. Okay. So we have our y-intercept, we have our slope. So we can write our two equations. We have slope-intercept form, we have y equals mx plus b. And we have a slope and a y-intercept for both situations. Okay, so we're writing two equations, one for plan one and one for plan two. So defining our variables real quick, we just want to make sure we understand that y is going to be our total cost and x is our miles driven. So make sure you're paying attention to what do the variables mean. So in this case, and you can always change these variables. There's no reason I had to use x and y. I just left it that way so that it looks like our slope-intercept form. So plan one, the equation is going to be y equals m, that's our slope, that's our change per mile. Per is a multiplication word, so I know I'm multiplying 13 by x. Every single mile is an extra 13 cents. And then I'm going to add that $44 because no matter what, even if he didn't drive a single mile, he has to pay that $44 if he agrees to rent this car or use this plan. All right, for the second one, now I have y equals 11 cents per mile. So I'm multiplying 11 by x, and I'm going to add the $49 initial fee because, again, that's his no matter what fee. He has to start at $49. All right, so we have two equations, and this is very similar to the previous video that I did where we had two equations in y slope-intercept form. So if I know that y equals 13 cents times x plus 44, I can interchange or substitute y for this expression, or I can take this expression and substitute it for y. I can kind of go back and forth. I can do the same thing with the second plan. I know y is equal to 11 cents times x, or per mile, plus 49, so I can substitute this amount for y. So we're going to use substitution. So they both equal y. Well, y equals y, right? The total cost equals the total cost. We want to know when they're exactly the same. So we want to know when y is equal to y. Okay? The two plans won't always equal the same. There's only one point at which they will equal the same thing, a certain number of miles where they will be equal. So we want to know at what point will they be exactly the same. When will 13 cents per mile plus $44 be the same as 11 cents per mile plus $49? Okay, so now that I have this written, I use my substitution. I'm going to start bringing my variables together. And again, I've talked about this in previous videos. When you have this situation where it's a variable on both sides and a constant on both sides, you choose that first move. Any one of these four numbers is not wrong. You just choose and you start moving to get like terms together. I tend to choose variables first. It's just for whatever reason the way I like to do it. So 13 cents minus 11 cents, we get 2 cents. We bring our 44 down. The 11 cents minus 11 cents cancel, and 49 comes down. And now I'm going to bring my $44 over because I'm trying to get x by itself. So now x is already on the left side, so I'm going to start moving everything over to the right side. So I'm going to subtract 44 because 44 minus 44 cancels. My 2 cents per mile comes down, and I have $5 here because 49 minus 44 is 5. So what I've essentially done here is I figured out what's the difference per mile. Well, that's 2 cents, right, in the two plans. There's a 2 cents difference there. And then what's the difference in the initial value? Well, it's $5, right? So I'm really coming down and I'm figuring out what is the difference in the two plans. It's 2 cents per mile and a total of $5 difference in initial fees. So now I want to know, okay, well, how many miles do I have to drive in order to get to $5? So I'm going to undo the multiplication here by dividing by 2 cents on each side. So I get, 2 cents divided by 2 cents cancels. 5 divided by 2 cents is 250 miles. So this is how far Eric would have to drive, 250 miles, in order for the two plans to be the same. So if we think about this really quick for the two plans, this could help us decide which plan to choose. Because if he's going to drive less than 250 miles, then he would probably want to go with the plan that costs less per mile, right? So $49.11 per mile because it costs less. Or I'm sorry, I said that backwards. He actually wants to go with the first plan because it's less initially, $44, and it's 13 cents per mile. So he's not going to get to that point where the 13 cents is going to make too big a difference if he doesn't go over 250 miles. But if he's going over 250 miles, now he does want to worry about the miles he's driving. Because if he drives a whole lot more than 250, that 2 cents is going to start to pile up on him. So he would want to choose this one, even though initially it starts a little higher, the miles don't stack up as quickly. And that 2 cents, if you're driving a really far distance, hey, 2 cents can definitely pile up quickly. All right, so the second part of this is what is the cost when the two plans are the same. So we're going to choose either of the two equations. It doesn't matter which one. So I went ahead and chose plan number 2. You just pick one of them. It doesn't matter. Because either one you plug in, you should get the exact same cost. You can actually test this and make sure that you do in fact get the same cost for both plans. Because you should, if you don't, something went wrong in our calculations. So we're going to plug in 250 for X. So I have 11 cents times 250. That tells us how much he's going to spend in mileage plus that $49 initial fee. So he's going to spend $27.50 on miles because it's 11 cents per mile, and then $49 for that initial fee. So I add together and I get $76.50. And again, if I plug this into plan 1, I should get exactly the same result. Okay, so $76.50. All right, so that's a word problem using substitution. I hope that helped, and I will see you in the next video.